should I give you a quick intro? Excellent. Good evening, everyone. Thank you for coming. It's my pleasure to welcome back Bruce Bell, and also welcome for the first time Oliver Thomas from Facit Technologies, also Facit Homes, and I expect Bruce and Oliver will talk about the difference. Bruce has been here many times before talking about the work they do with Facit Homes, which is interesting in itself, and I think you'll give us the background to that. And it is a unique way of manufacturing buildings, and has been described as so. They were established in 2011, so they've been doing this for a while. And I think the current kind of development, I think, which we would talk about a little bit this evening, is the kind of idea of how you might scale that process up. So start suddenly not making individual homes, but actually suddenly making 10, 15, 20, 100 houses kind of development. But still with the ethos, it's lightweight, it's made of a sheet material, it's sustainable. There's a lot of interesting things about this technology, and it's fascinating, and it's so good that you've been doing it. I'm just interested that can't wait to see the next version. So thanks so much for coming back. Appreciate it. Have you got your own mic?
I haven't got a mic here yet. There we go. Hello.
Well, maybe we could have witness do that.
Yeah, all right.
Sorry.
So I'm going to give you a little bit of the history and backstory of Facit, Facit Homes, and then Ollie, who joined us earlier in the year, is going to talk about Facit Technologies, which is the kind of next phase. So I'm going to talk about where we've been and the kind of stuff we've done. Is there a clicker or something, or is it just a keyboard? Yeah. So broadly, Facit Homes, we are a designer, manufacturer of homes. At the moment, we've been building homes for private clients. So customer comes to us, they have a site, and we do everything from concept design, manufacture, construction management, fit out, everything basically. Everything from planning, services, utilities, all aspects we see. And what we try to do is digitize the whole process as much as we can. So using digital design, using digital manufacturing, which we'll show you a bit more, and try and deliver the home as a kind of single product rather than a separated kind of lots of different people doing different things approach, which quite often happens in construction. So I'll show you, these are just a few of the homes that we do, but broadly, every home has got a customer, they own the site, we're not a developer, we don't sell houses, we're an expert designer and manufacturer of homes, and each one is unique to the customer. So just a bit of backstory about me. I trained as an industrial designer in the 90s, late 90s, and then my first job was at Norman Foster's Architects in 1999. I was there for 3-4 years, and I worked on this particular project as well as many others. But this is Chaser Futura, which is a residential property in St. Moritz in Switzerland, and is timber construction, digitally designed. We worked with the Advanced Geometry Group, or I can't quite remember what they were called then, they were called something else, which was, they had a specialist modelling group within Foster & Partners, complex geometry. It had a digitally manufactured timber frame beneath it, quite complex detailing, very accurate, and kind of hand-finished as well. So all of the timber shingles on it, there was a kind of real craft to the building. And that was probably, a bit of industrial design background. Seeing something like that, there was something that I thought was super interesting. So after Foster & Partners, I went to the Royal College of Art, and I did all sorts of experimentation with digital technologies that I knew were out there in industry. So laser cutting, wire bending, CNC press punching. There's lots of different available technologies that I produced things with, just to understand how you might build, how you might make, as somebody who's not naturally a maker, because I was actually on a design products course at the RCA, which was quite designer makery. but I'm not really a maker by nature. I'm very good at computers, but not really good at anything if I'm actually touching it. So I went through this process, made lots of things, discovered all these technologies, and then after that, I ran an architecture practice with some architects who I met at Foster & Partners for 5 years, and it was awful. It was a really challenging experience of working on small projects with small clients, but through that process, I kind of decided to try and see what we could do using digital technology. And actually, just go to the next one. Let's just see. I think it's gone funny. There we go. So this is me in front of our very first proof of concept in 2007. So at that point, I had this idea that we could use CNC cutting or CNC routing, which is pretty standard furniture-grade machinery, to make homes. And we got some funding from the Greater London Authority to kind of prove it as a concept. And we designed it, I think at the time we designed it in 3D Studio Max, or parametrically in 3D Studio Max, which was impressive. And we designed it, we manufactured it, we assembled it. It pretty much worked bang on exactly as we expected. It was a 2-story prototype in front of the Architecture Foundation space, which was then on Old Street. And it kind of said to us, well, this is definitely a thing, we could do this. And from that point, I kind of set about leaving the architecture practice behind and trying to get this off the ground as a thing in itself. So going to find some real customers to build some real houses. And we didn't have a workshop, but we knew we wanted to use CNC. We didn't have a factory, we didn't have any money. We had a couple of customers, and we had access to hire finance loan. So we could buy the machine over time and pay it off. And so what we decided to do is, rather than make it off-site just through necessity, we were going to bring the CNC machine, put it in a container, and bring it with us to the construction site. And that way, we didn't have the cost of shipping, we didn't have the cost of a factory or any other overheads, and we simply figured out how to put the machine in there, figured out all the wiring and electrics and transportation and all the various issues around it. And we started manufacturing there and then on demand as a kind of methodology. Actually, Ollie, could you play the video for me? So we've been working in this way since 2011. And so this is our machine, it's on site. We drop it down, we drop the materials down, we load up the files which are remotely operated from the studio, sheet material, super simple training, 3 days training, 3 days to train and operate the machine, and also to assemble the components. So it basically does its own thing. Cutting out quite complex parts, we're trying to design in complexity into the parts, but they're simple to assemble. So they perform whatever task we need them to, so service channels, details, falls, drainage, whatever it is. So we end up with big wooden Lego. They're all parametric, so we can change the size of any components, whatever we need. Make it, fabricate it, assemble it, install it. So it's a very, it's quite traditional, like turn up on site with some materials, with some people, and you build some houses, which is what we've been doing for centuries. So again, a kind of transformation of thinking around house building as opposed to a revolution. Thanks. So yeah, so we've been doing that for a while. And then the first thing we have to get is, yeah, you're right, you're going to CNC your house, but you got to dig some holes and put some drainage and put some foundations in. And this is that day one, on the first day of the first build, we've got a CNC cut jig to guide a screw pile into the ground. And we're asking ourselves, again, how can we leverage digital technology in something that's incredibly analog and incredibly messy? So we try and apply the philosophy as we can to everything and see if we can apply that. So between 2009 and 2012 are our first kind of prototype projects. They were collaborative. We weren't always the designer. We weren't always the contractor. We were working with self-builders, and some of them were good and some of them were not so good. And I think at that point we decided that we would try to become both the designer, manufacturer, and contractor, because the outcomes from what we'd seen so far were quite variable. You know, sometimes you've got a good client, sometimes you've got a bad client, sometimes you've got a good contractor, sometimes you've got a good design or not. So actually just pulling all those things in together meant that we could be sure that the quality would be good. It's a bit blurry. Should we do it off the other deck?
Yeah, I think maybe the internet.
Yeah. So
Internet's a bit dodgy.
this one's
good.
This is okay. But at that point, we decided that what we would try and do is think of the home as a product. So philosophically, every home would have the same foundations, the same roofing, the same flooring, same heating systems, door sets, and in the middle, the bit that we manufacture, which we call the Facit Chassis. So like the chassis of a car, it's ready for all the other parts to fit to it. It's not, you don't have to rework it to finish it. But we're going to reconfigure the systems using digital design technology. So the critical thing about the chassis is it's not just the superstructure. So it's superstructure, floors, walls, internal walls, door portals, window portals, like parapet details, all the kind of fiddly stuff that you might get a carpenter to do. But also in a kind of typical house, every single element would be a different system. So you're going to have one system for your external walls, one for your roof, one for your floors, one for your internal door frames. And, they'd all be separate. And what we do is we pull them all into one process, and then we put them all through the same digital funnel, and that's where we get the scale, the capacity, the accuracy, and the kind of numbers behind it. Thanks, Ollie. So 2013, what we call the first proper Facit house, where the whole kind of philosophy was starting to come together. So digitally fabricated solar shades, digitally fabricated cladding panels, digitally fabricated staircase, superstructure, chassis, and it had pretty good outcomes. We learned a lot. It was the first time we were main contractor as well as designer, so we had doing a lot of learning on the hoof. It was our first turnkey contract, and it was good money. Actually as a contractor and a designer, you're getting the design fees, the production fees, the construction management fees, the whole lot. So, it worked as a financial kind of idea, and so we kind of just trying to accelerate it off the back of that. So on the back of that, we kind of realized some of the shortcomings in terms of delivering the project, and we realized we were designing in Revit at the time, and we realized there was an opportunity to make more of the BIM information. So if you really work in Revit and really work the tool, you can get to do anything you want. Most architects are kind of limited in what they can achieve because they're only really paid to design. We were being paid to deliver the construction, and there was more value in it for us. So we produce engineering grade BIM models that we're going to go directly into manufacture from. So we'll spend a long time building assets. So like a window family or like a structural family or whatever it is, we'll really work those assets so that we can get really accurate quantitative information or production information. So for example, the windows, we rebuilt the window supplier's product with all the options and features that we knew it had, so that we can get final finished frame sizes and they can put it into their production management system, as opposed to just kind of them measuring off drawings, and there's a lot of back and forth and it's very painful. So with the system that we built, it takes production information from the model and it goes straight into manufacture, so from digital to real. And we're trying to produce as many different features in there as well. So we've created a kind of feature-based modeling system that we built ourselves from scratch in Revit. So any of these components, you can say, well, I want it taller, wider, I want it to have a service channel or no service channel, or a parapet detail, or whatever it is. So the actual design features in the Revit model are really simple, and they're usable for the architects who we have designing, and they can make decisions, and it doesn't have to go to specialist engineer to do. It's just quite usable tools. And then from there, we've created a process that just downstreams information. So we can bulk outload data from the BIM model into production, and we don't need to go kind of back and forth between different systems, which you see quite often in large architectural projects where you might have engineer working in Tekla or CATIA, and then you've got the architect working in Revit, and you've got kind of that data transfer between different platforms, whereas we just focus on one single place, source of truth, and everything flows from it. So we've been evolving and repeating this process over and over again, and it is more a process, more of a methodology than it is a singular construction product. So we're continually changing the rules on whatever we need to do. So at the moment we're developing an open panel version of it, and you can see there the kind of level of detail in the components there, whatever they need to be, and we continuously adapt and improve, and we're more focused on the kind of systems design than the actual product, because if we automate the systems design, then the product can be whatever it needs to be. And it's quick and simple. So for now, for us to go from our current components, which are more of a kind of closed box with insulation blown into them, to an open panel box, it doesn't take us very long at all. We just do it. There's very little cost penalty to us. And the manufacturing process hasn't changed. So to date, we've cut 37,000 sheets worth of ply. That's a lot of plywood. We're a tiny company, but we're one of the biggest plywood buyers in the UK. Just because we buy each of our projects is 1,500 to 2,500 sheets of plywood. Most contractors are buying 20 sheets. So, again, that kind of volume allows us to make it economically viable. And with the 37,000 sheets worth of plywood, there are 37,000 unique G-code files that have to be fed into that machine. So again, we work collaboratively in the studio, architects working with production engineers, side by side to create processes to not go mad, so that you can handle large levels and complexity in data. And that is probably the real core of the business, is that collaboration between industrial design and architecture and construction. So we literally sit side by side and everybody kind of works collaboratively. It's not siloed in any way in the business, and that reflects on how we do things on site and how we build. So research and development is a core part of the business. If you're from an industrial designer's kind of background as I am, most production companies like, let's say, Apple or a car company or a bike company, they put money of part of their revenues into research and development, and that's what we do. So we're continuously improving our processes. At the beginning, we were more focused on the kind of core product development around the chassis, whereas now we're more focused on kind of back-end processes, which just create efficiencies through the business. So our kind of construction management platform that we've developed, or all sorts of things that we create. Thanks. So lots of houses that we've built. So each one of them has got some individual client. They're all different shapes and sizes. Some are really fancy and some are less fancy. Some of them are quite ordinary. And so during this time, so this is the last 10 years, we've been kind of trying to improve our processes, like how do we manage quality? Because we're doing everything. We're literally contract managing it. We've got people on site. We're looking at tiling defects and just the brutal reality of construction, that we're trying to get the quality and detailing that we really aspire to. And how can we manage a site at a distance as well? So our projects are all over the place. We've just finished a house in Scotland. We've got one in Suffolk, one in Chichester, and that requires kind of a particular approach. And also, critically, how do we price as well? So understanding your pricing structure and making sure you're able to tell customers exactly how much it's going to cost in advance is so powerful. At the beginning, we were just kind of sticking our finger in the air and hoping for the best, and then at some point you figure out how much it costs and you go back to your customer and beg for forgiveness if it's too much and jump for joy if it's okay. Whereas now, because the kind of system that we built, we just know in advance exactly how much it's going to cost with some very simple information, which is extremely powerful because that's what customers want to know. They're just like, most customers don't get to know how much their building is going to cost until too late, whereas we can tell them up front. So that's probably one of our strongest kind of points with customers. Yeah, next slide. And yeah, so we've got houses 6 to 28. We've got a lot of kind of customized interiors that we have to deal with, which is not, none of this stuff is particularly specialist to us. I mean, we've done, apart from the kind of maybe the laser fabricated staircases, there's a lot of just regular contracting that we have to deal with, plastering, electrics, but we try and analyze these things and we try and extract data from it. So we've got a time tracking system that we built that measures every single bit of labor on site that we categorize, and then we use that back into the process. So if there is data to be collected, we'll try and collate it. And thinking about defects as well. Defects are killer in construction. If your property has defects, you're back there fixing it. You're losing money day after day. So a lot of time is spent in just how do we minimize defects down to as little as possible, and how can we, take reasonable risks and try and do something exciting, but at the same time, just not lose our shirts. So quite often we iteratively try new things. So each project generally has something new that we try and do, but we don't try and do too much new stuff on the project because we know we'll just make too many losses. And yeah, so the philosophy is built as designed. So we're really focused on getting really good design information and then following it through on site and not being too swayed by people, because a lot of you get contractors on board and they're like, this is never going to work, you can't do it like this. But actually, now we know enough to say, no, we do think this does work, this is what we want to do, and it allows you to just deliver on what you said you would in the first place. Occasionally something happens and you've got to change your details because of warranty or whatever, but we try and just deliver what we've got on the drawings from day one. So the back-end processes that support it, we've got real-time data kind of running through the business from, as just described, kind of picking up timing, the costing system, where we can essentially take some really simple geometry, like the ground floor, size of the ground floor, amount of external walls, internal floor area, just really basic, like fag packet maths, and we can put that through our costing system, and that will give us costs to about 1% accuracy. We've got bunch of digital assets in our libraries that we leverage and we regularly upgrade. And then we've got the remote construction management process, which is taking 360 photographs every week and continuous dialogue with the people on site. And then the supply chain as well. So we kind of built a kind of platform which is for multi-purpose. So we built a platform which is using Airtable, which is like a no-code platform, which is really good fun. And in that, we built a system which is for the design team to choose the specification, the client to see the specification, and the order management team to actually go and procure it. To have, you need 50 boxes of screws. Each box has got 200 in it. Like just a really granular level of data that means that we can operate really effectively as a team. So people at the beginning were like, you're manufacturing on site, you're crazy, why would you ever do that? Factory is the future. And this is back in 2011, 2012, when people weren't really doing modular at the time. And then from then, we've seen these big companies go into modular off-site fabrication. We tried it as well for a while. So we have spent 3 years building stuff in a factory and shipping. And it was awful. Like we spent all of our time mitigating problems, like tessellating stacked components, loading them onto the back of a truck, stacking, packing, lifting, and you get these situations where your site is just covered in components because you just received a massive low loader full of stuff. So we realized that it really is more effective to just do the manufacturing on demand, because this stuff just comes out of the machine when you need it, and then you put it where it's required. So you just don't have that inventory, that stuff between the production and the house. So, you know, quite often when you're ordering stuff in advance, if you get delayed, they're like, you've got to get this stuff out of the factory, and you're like, and that's why your site gets overloaded, because whoever's making it for you, their factory space, they don't want it hanging around. We get stuff damaged, we get stuff lost. I mean, like, you look at the size of these stacks, and you're like, oh, where's component 51.3? And it could be like, you know, the bottom, literally at the bottom of that stack at the back, and you spend hours trying to find it. So it was really ineffective. So we now really understand the value of the on-site manufacturing, because it's just a really simple process. So we've also tried a lot of different, like, groundworks for civils and infrastructure. We have built beam and block foundations, screw piles. We've tried, like, spray painting templates on. We've tried lots of different ways of doing groundworks, and we've done it ourselves, digging trenches and getting in there. And we've learned a lot through that process. So we kind of took it upon ourselves to make sure we knew everything about every single process so we could control it. And the, thanks, Ollie. Oh, that's better. Yeah. So you can see there, so that was the first version that we did with a kind of raised ground floor and screw piles with a timber infill. And then this was kind of somewhere in between. We did a insulated beam and block system. And then down the bottom is the system we use now, which I'll show you in a little bit more detail, which is like a passive house raft insulation system. And it's so important that we take hold of those groundworks so that we can secure the rest of the project. There's nothing like saying, oh, I'm just going to give these groundworks to somebody else, or my customer, for example, because it would just delay the whole project. So it's become a necessity for us to take on the groundwork so that we can plan the rest of the project. And so this is the current system that we use, which is a passive house standard raft system. So it's super lightweight, really easy to install, really clean. It's 300 mil of insulation in the middle, and then you end up with like 100 mil of concrete topping at the top, which is about the minimum amount of concrete you could possibly use. It's got your underfloor heating buried in it as well. You can add piles in, so if you've got poor ground conditions, you can add micropiles, which is what we do. So micropiles is like a steel tube, like hollow, and you just drive it into the ground with a tiny little rig. It's very cost effective. And it's very simple to understand the information and compare it against your BIM model. You know, things like we used to find that with the beam and block, although it's quite simple, beam and block, you actually get these kind of layers of different directions of block work below the beams, and it's kind of difficult to see, whereas this is just super simple. If you go to the next slide, this is the design information for the slab, and it's so simple. It's just the setting out points for the edge, occasional penetrations for surfaces. This is the thickening, and that's literally what it looks like on site. So again, we can use the information that we've got to make sure it's well quality managed, and make sure that what gets built on site is what we want. And to pick up those small errors, there's nothing like getting to putting your superstructure, your timber frame on top of it, and discovering, you know, something's out by 100 mil. You know, so actually just simple methodologies really helps us. So we've done a lot of prototyping over the years as well. We build, so this is staircase fabrication, laser cut, folded. So we do all of our own shop drawings in-house, and we have a laser fabricator we work with. So, you know, that's like an aluminium window pod around the window. That's one of our own manufactured products. Staircase prototype down the end here. That's a internal wall development prototype that we built recently, and you know, it's part of the process. So we'll design it, produce usually one prototype, build it, put it together, kick it, see how it feels. Because especially with something like a staircase, it's always very hard to tell. So we build the steps, you literally jump up and down. Does that feel good? Should it be a bit thicker? And it's the kind of stuff you can't really do with an engineer, because the engineer, if you give it to them, they'll just make it like 20 mil thick sheet steel. And so actually just taking that time to figure stuff out ourselves, the engineers will usually kind of just say, yeah, your fixing's all right, it's not going to fall off. But that's the difference between how rigid or how much flex a staircase may have, because quite often steel staircases are okay with a little bit, but then at what point does it just feel floppy and make you want to run away? And yeah, so that's the business as it is today. So we've built like £30 million worth of construction, 28 quite large properties that we built. I think we're on 29 at the moment. We generally build in about half the time that a traditional contractor might, broadly through just being organized in advance. I think that if you think about what it's like to be a regular main contractor, you've just got your architect's drawings, you don't know what it is, you've won the project, your QS has priced it, and you're like, right, what's this one made of? Oh, this one's made of steel and something else. What window product is it? Okay, it's this. You don't really understand it, so I think it's quite challenging in a kind of regular contracting framework. Whereas, because we know all the products and we've done them time and time again, it allows us to plan in advance of a hitting site. So everything's streamlined and there's a kind of repeat process, but each home is completely different. I think that's it for me. So what Ollie's going to show you next is where we're going. So do you want me to introduce you, Ollie? Do you want to do your own introduction? Okay, so
I thought maybe you could we could talk through this last one.
Yeah.
Just to explain, to tie the full process together. Maybe Bruce, we got the foundations and.
So you've got the underfloor heating going in there. You've got the superstructure going up. All the various different components. We've got breather membrane, so like a combined breather air tightness membrane. Cladding systems, so that's the kind of the whole process really, and in some ways it's not that radical. A lot of what we do is try and revolutionize the back end processes and the overall philosophy and the bringing together of it, which you could apply to any different building typology, to be honest. And we try, in some ways, we try not to revolutionize too much because we still got to get warranties and mortgages. And if you go with a novel construction to a lender, or because there's always some kind of risk lending where your customer's got to get a warranty and a mortgage and insurance and all that stuff. So you have to be really careful with what you're putting out there. Is that can I introduce you now?
Yeah.
All right. So Ollie. So Ollie joined us earlier in the year, coming over from Björk Ingels Architects as a design technology manager. He's joined us as a co-founder, as a director into Facit Technologies, which is how can we scale up this kind of approach to larger projects? And actually, we've been working before Ollie joined for about 2 years, trying to figure out the next steps and how we might kind of get this up off the ground into something larger. And Ollie's joined us to kind of push the whole thing forward, really. Anything else I need to say?
No, that's
Great.
it. We'll jump into it.
I'll let you do it.
So yeah, I mean, I joined Bruce from Big at the start of the year. So I was kind of like the BIM guy, the computational guy, the AI guy in the office. I was working, Amy was part of the office back then. It was it's a pretty crazy but fun environment in a way. So you get to test out all these tools and technology in a design space. But here, I think it's interesting that we can apply it on a much broader scheme, from design to manufacturing to assembly. So Facit Technologies, we're now scaling up this. You can think of it like how Tesla started, right? You start with the Roadster. So those houses are expensive, beautiful, sustainable homes. They are like our Roadster. And now, as we can trickle the technology down, we can build more affordably and also build more homes. So the next stage is to build more kind of, mid-level priced homes. The reason why we do this and why now is really important is because the way that we currently build homes are collapsing, and the new way that we've built homes has completely collapsed. So traditional construction, and just if you're unfamiliar, what is traditional construction? That is when you get an architect to design it, you then go find a contractor, and the contractor is usually, in the housing world, you're building out of bricks and concrete and all this kind of stuff, and it's messy. People don't want to do these jobs anymore. The cost of this labor is going through the roof, and it's not really adapting technology and can't really scale. And on the other end, there's this world of modular and volumetric, of building factories to make homes out of it. Sounded like a great idea. It's a terrible idea because it's so expensive to build a factory. You're literally spending 50 or 100 million quid on a factory. There's now at least 10, maybe 12 companies at this point that have spent literally hundreds of millions, 100, 200, 300 million on this, and they're dead. And they've made like 100 homes. And the reason why this is because it's so expensive to build a factory. Any kind of efficiencies you get from building the factory, you lose because of the cost the factory requires, and also the transport. You're now transporting loads of boxes every room. You got to like ship down the motorway. So the same concept of thinking of the home as a product scales up. So like Bruce said, we think of the home as a product, meaning that we just reconfigure the same parts. We're not copy and pasting the same home like, Barratt homes you see, it's the same typology. We kind of parametrically can design any shape or size of building. That's why every one of our buildings is unique. And so now we can apply that to terraces, townhouses, apartment blocks, like up to 5, 6 stories, which is where we really see housing impacting the most. Our innovation is, of course, our microfactories and building on-site. And so now we've developed a new microfactory that can cut more and build more. And we kind of blend the benefits of traditional on-site construction and some of the benefits of off-site construction in this completely new way where we're utilizing technology, we can quickly bring it to site. We're not using as much labor, but we still use labor. And most importantly, it's low CapEx. CapEx means capital expenditure. It just means basically instead of spending 300 million pounds on this, you can spend 600 grand. And so it's like super, super tiny numbers in the grand scheme of things. And we can build faster and we can build cheaper. So this is our new machine. So we now have a 3-container machine. Our CNC is still in the middle one, but then around it we've built automation of material loading on, material loading off. The microfactory is still the same essence. You've got materials coming in, the components are assembled, and then we can also add components together to make full walls or full floor build-ups, and then they're craned in place. We then deploy the microfactory immediately on the building site, or as close to the building site as we can get, and we can build the houses out of our Lego blocks very quickly. And each microfactory can build 80 to 100 homes per year. We can ship them anywhere and deploy them and start building from them directly. Inside the microfactory, it looks a little bit like this. So at the core of it is our machine. And then we're also utilizing as much technology as we can to assemble, like augmented reality for assembly. Again, conjoining the components into a full floor or wall build-up that can then be craned into position. As you can see, it's a much smaller setup than a giant factory. This is our mean-looking machine. And it's really about taking technology to the building site. Instead of getting robots to assemble your components, which will be a nightmare until we have like Elon's robotic humanoids doing it for us, we can supplement people with augmented reality, and you can just see how to assemble the components rather than reading drawings. So we've been developing this new machine with a company called Tharsus. Have you ever heard of Ocado, the food delivery thing, right? So have you ever seen there's these machines that go and collect your food? So Tharsus made that, and they pioneered that. They made the robots for Ocado, so we're working with them to do the same kind of thing, we're not delivering food, but we're going to be creating like all these different automations around it, which looks like this. So this is our new machine. In the middle is still the CNC machine, but then we've got like material loading on and off, 2D printer, buffer rack, and this means 2D printing is we can print instructions onto the faces of the components. The CNC machine is doing its thing. The loader is like a sleight of hand trick. It loads and unloads at the same time. And the buffer rack means it can like run all night, right? And so you come in and you got a whole bunch of fresh sheets ready to assemble. The 2D printing basically looks like this. We can print instructions onto the faces of the components. You guys, you maybe have a bit of experience on site. If you ever make a drawing to tell people where things will go, they will not read it. Okay, so you can guarantee things will never be quite in the right place. So this is kind of low-tech, high-tech solution where you literally print instructions onto the wall, so you cannot ignore it. Also, you can print like QR codes. So later on, you could attach like an augmented reality. So you just look at it through your phone, and boom, like an instruction shows up. So we can simplify that. And we're also looking at using other people's technology. So we can print on our components and stuff, but the slab, for example, that's the kind of analog part where it's still poured manually. So it's still like, it's accurate, but it's not super millimeter accurate like we get with the chassis. So we're experimenting with this little robot's called the HP Site Print, and it will actually print your plan onto the concrete slab. So then in theory, we have accurate laying out of our digital components, which is a big part. We spend a lot of like measuring that things are in the right place. So it's like using technology, again, like using soft technology, where augmented reality, where we can aid the assemble. So now with what Bruce showed you, with the first microfactory, we've now developed like a mid-level microfactory. We call it our MVP. That's your minimum viable product. And our all singing, all dancing Facit Chassis printer by Tharsus. So depending on the size of the projects, we have different size microfactories for different projects. This is maybe a little bit technical, but there's two really key things here. So first of all, this is the size of our factory compared to, this is our microfactory compared to a fixed factory, and both can produce around 100 homes per year, right? So there's two reasons why factories really struggle to work. One, they just try and bring inside the way that we build outside, right? And what that means is they try and automate like the processes that we have already, which means they'll have a line for the roof truss, a line for walls, a line for floors, and they buy all this heavy machinery to try and automate those processes. That's why you have these multiple lines of production, and then they assemble it into like a box and then ship the box on the back of a truck or something. Ours is the complete inverse of that. So we have one methodology to make walls, floors, window pods, all these different kind of components, meaning that's why we only need one machine. We don't need like 20. That's why our microfactory is micro. The other thing is the cost, right? So your factory with your cost of the machinery, the transport, inventory, rent and bills will cost you about 12 million quid a year. If you're producing homes, that's 120 grand of your home, which is just for your factory. So you're already that much in the hole before you've even done anything else with the house. For us, it costs you 240 grand a year. So we're talking like 1 or 2%. It's almost negligible how low cost the microfactory is. The other part is like some of the stuff I'm starting to bring over since I joined was automating with the tools that we have. So bringing in Rhino and Grasshopper that I was using a lot in my last few jobs, so that we can go, can we generate designs and move very quickly from Rhino to Revit. At the moment, the chassis, we're trying to use computation to place it instead of manually placing all the components. Can we automate drawing? Can we train ChatGPT in our building system so it becomes like a wiki for some people using it? And so, there's a few examples of some early experiments when I joined of going from like a design model to the Facit Chassis, so we can generate the chassis a lot quicker. This more recently was like experiment of going from a very simple wireframe model to like a fully designed project, drawing automation. And so now we're developing the ecosystem that Bruce talked about in a much more robust way where we're improving costing. Essentially what we're offering is like we see ourselves as like a tech-enabled house builder. We have this process from development appraisal all the way to selling the home. And we can empower developers to tap in to our technology and build faster and cheaper. So a developer may already have a design. They've gone to like Big or Heatherwick and have designed something cool, but they want it to be built in our building system. We can pick that up, go through the technical design, buy all the materials, build it with our micro factories, and maybe give them a bit of help on site. In other cases, we will actually, a developer may come to with some land and we do the whole thing for them and even go to the selling stages. And what we really offer is we can build 50% faster than traditional construction. So again, you guys may not be familiar with this, but the way that it works with traditional construction is often, you hire an architect, they design you a super cool house or apartment block or whatever. You pay them a lot of money to take it through stage 3, stage 4 of the RIBA stages, and then they go, oh, here's a bunch of contractors. How much is this going to cost? I wanted to spend like 10 million, and they come back and it's like, this thing's going to cost you 30 million, and you're like, what? So then you go back, you shout at the architect, they redesign it, and this process can take months or years. And we can cut all of this out, because as soon as we're designing, we know exactly how much it's going to cost from day one. So we cut out all of that, and whilst we're in the planning process, we can also streamline going into the technical design process. The modular and volumetric guys, even though they have their own factory and they can streamline the design process as well, the problem with having a giant fixed factory is you have to wait for your queue in the factory, which can also take 6 months. For us, we can just send new machines and send new microfactories. So we can speed up construction by a lot. And we can also empower developers to build at a lot lower rate. So again, this might be somewhat new for you guys, somewhat not. So the way a traditional contractor, a traditional builder is, like, traditional builders don't really build anymore. They take a ton of money and then they say, you're going to build the timber frame, you're going to do the bricks, you're going to do the insulation, and they hire it, they subcontract it out to a bunch of people. And so that means you're making your profit, you're making profits, you're making profits. And then, because it's so risky that I'm relying on all you people, they basically charge like a massive margin of risk, right? The house builders, like Barrett Homes and things like that, they have all of this process under one roof. So they have their own products, like they have their own typology of house that they use again and again. They have their own frame, maybe manufacturing capabilities, and they have their own supply chain of materials. So what we can enable others is you can tap into that using our technology, modern day technology, and build at a much lower cost, like people like Barrett Homes can do, and the small guys can't as much. This is supposed to be a GIF, but essentially now we're trying to scale up from houses to terraces, townhouses, apartment blocks, everything up to about 5 stories. As you can see, it's not like, it's really beautiful, simple, nice design, high-performing, sustainable home. And I think that's where we really see ourselves as the next tech-enabled home builder, where we're using technology to build sustainable homes through a complete revolution in digital manufacturing. You can check out, so we still have the 2 sides of the business, Facit Homes, that's like the consumer-facing side. Eventually, you'll be able to buy the homes that we build with Facit Technologies. Facit Technologies is more what's called B2B, that's business to business, where we're facing the developers and we're selling our technology or building with developers directly. So yeah, you can check us out. That's basically the end of it. If you have any questions, we can shoot them.
Thank you. That's brilliant. You got some questions there? Yeah.
I have a very simple question for you. How widespread is your company?
Sure. We're very small. So at the moment we're 7 in the studio. We're based in central London, and then we have crews out on site depending on how many projects we have. So sometimes we're a little bit bigger, and sometimes we're a bit smaller depending on what's coming through the studio. So we typically have 6 or 7 employed on each site, and then plus the core crew back in the central London office.
Are you open for internship?
You know what? Somebody asked me the same question yesterday. Unfortunately, with us being so small, we just don't have the support framework to have interns in, unfortunately. We need to get a bit bigger so we can look after people a bit better. But it's definitely something we want to do, but we're not quite ready.
I also want to input that with this kind of company, this is pretty much, in my eyes, revolutionary to many countries, especially countries that are struggling. So with this company, I believe that this would change how we see construction in the future.
Well, we hope so. I mean, what we'd like to do is get out to places like Ukraine when the war ends, and it will eventually, because they're going to need solutions that are transportable, that use local labor. You know, one of the things we didn't talk about today was the labor aspect. There's a kind of element where we're not drawing resource away from communities, that you're bringing technology in and you're creating local jobs using technology, and there's a kind of direct benefit there. I think a lot of people in the UK, so for example, councils, if they're building a housing development or they're a joint partner in a housing development, they don't really want to see the houses go out to a modular company who might be several hundred miles away. They want to see the benefit of the revenues coming into their community. And there's a similar thing if we go out to somewhere like Ukraine, where it can generate money in the environment without drawing away from them. So we definitely think it's a kind of appropriate use of technology.
Hello. You just kind of spoke a little bit about international, expanding internationally. What challenges do you think you would face with working in other countries with like different regulations? Obviously, as like putting yourself in the contractor position and like the responsibility that architects have and how that's growing. How would you manage that, especially with, you know, other countries that aren't maybe aware of this technology? And yeah, I mean, you kind of know from Big, we do a lot of international work, and we find that it's quite difficult to
So
implement it.
I think one thing, I think the unique advantage we have is timber. We're just building timber frame houses. It's not the core part of it is essentially, it's still a timber frame house. So in America, that's everywhere. Well, North America, it's everywhere. Europe, it's everywhere. So when you compare that with like 3D printing, for example, 3D printing is completely new. And so there's many places in the world that have to review the regulations and jump over that. So in terms of how we build, I think we can build anywhere. In terms of like as an architect, you know, in terms of building regulations and all that kind of stuff, I think it'll be part of like partnering and kind of working with maybe local architects, a bit like we sort of did at Big, where we are kind of the design flavor, but you're working with a local architects as well, and you're kind of combining local knowledge on the design side, but also on the build side. Like we can supply them our microfactory and use our building system, but they would have the connections with the local workforce and plumbers and electricians and stuff like that. So I think we, unlike a lot of other factories, like modular companies, can really utilize local labor, whereas the others are just kind of like shipping stuff from a factory. I don't know if that.
Actually, on that kind of point, the plan, if we can get this off the ground, is to productize more of the buildings as we go, right? So we want to be able to do bathroom pods or bathroom. It might not be a pod, it's probably going to be more like a bathroom stage set. So kind of wall panels with bathroom stuff already attached, cladding panels, staircases, anything where we think that, well, actually, modular MEP as well is really one of the key things we want to look at next, actually. There's a really good company in the UK who already do it with using CNC cutting. We want to partner with them. But the more we can productize over time, the more we can solve construction problems and solve our customers' problems as well. So there's a kind of like philosophy of like, if we can solve a construction issue with a product that we can develop, then we do.
Thank you. And also, do you think that this, the process could be applied to other building materials as well? Is it something that you see as like transversable to?
Yeah, absolutely. I mean, I think actually the one thing that we do is universal. You could apply to anything, right? Which is don't start from scratch on every single building. Like, start with some philosophy and then learn and do something else. You could do exactly the same. In fact, there is a company in Holland, I think, who do like CLT. I think they're called Finch. I think they're Finch. They take the same approach, but they're doing like a multi-story apartment in CLT, right? And there's Cree, who are in Austria, who take the same approach, but they do it for office blocks, using a kind of combination of CLT and something else. So you can, if you think about that, then maybe the future for lots of building typologies is the same approach. And quite frankly, you could do this same thing without it being digitally manufactured, and you do a hell of a lot better than most people. So I think the philosophy of thinking of the whole thing as a single product, evolving details over time, and not just starting again from scratch is for me, I think would be much more successful. I think it's very challenging when you're just redoing everything over and over again from scratch with a new designer, a new architect, and yeah.
Thank you so much.
Thanks. More questions? Yes.
Hi, you're right. I just wanted to ask, where do you guys see your business being within 5 years, and what type of plan do you aim to take to get there?
So I think with Facit Technologies, we're looking right now for pilot projects. So we're initially looking for projects where we can scale to like 10, 20, 30, 50 homes in one plot. And we want to build up from there. In 5 years, who knows? We could be building a shit ton of homes, or we could be building just a few homes. I think we want to scale. Every year we want to be building more homes with our technology, building more micro factories. 5 years is a short time, I guess, in the housing space, Bruce. We could be building a few hundred homes per year, but we want to scale to maybe building thousands of homes per year. But there's a lot of different factors of like what's going on with the economy, what the government want to do in terms of building houses. But hopefully we'll be building a lot of houses. And we'll also be not only in the UK, but we'll also be expanding to the US and Europe by that point. So hopefully in 5 years we'll be building a good amount of homes in the UK, US, and possibly Europe.
I think one of the things we've been doing this year is just trying to figure out exactly that question. How do you scale? And so we've been out talking to venture capitalists and developers and trying to understand the stuff that we don't understand. We know nothing about raising money. We don't really understand, we didn't really understand what developers are, but now we're really starting to understand. And we've been speaking to these development companies, some really cool companies that we've been following and have a kind of relationship with, who are doing nice architectural kind of projects, housing. And we've been speaking to these guys for over a year, various different companies. And it's only now, literally in the last 4 weeks, that we've found out that developers aren't what they seem to be. A lot of developers are development managers. And I was like, what's a development manager? And that means that they don't buy the land. So quite often the land is owned by someone else, which could be a fund, it could be a landowner, it could be anybody. And they get paid as a kind of consultant. So the idea that developers are a company that buys land, puts the houses on it, and then sells the houses is so often not the case. And so you have to understand the mechanics of what is a developer? How do they make money? How, what's the risk? Where does the money come from? So we're kind of learning all this stuff. So we've got an amazing product, and we understand how to build houses. The next challenge for us is really to understand what developers need. And I think we're making progress on that, actually. We're finally kind of really understanding. And now we have a bit more of a plan. We can go out and say, right, this is what we want to do, and this is how it's going to work for you. So particularly the kind of financial model that Ollie talked about, where we're enabling others to act as a house builder, is quite critical, because most of the developers who we talk to who want to do something vaguely architectural or architectural with an architect's design, they have to go out to a main contractor. So one of our potential customers is Igloo Regeneration, who do some really cool regeneration projects all over the UK. And they always go out to main contractors to build their properties, but they've had 3 main contractors go bust in the last 2 years. and they're multi-million pound schemes. And every time they go bust, it's an absolute nightmare because you've got a half-built building. Quite often you have to like raise it to the ground again because you don't know what they've done. You lose tens of millions of pounds and you know, start again. So they're looking for different ways of delivering, different procurement routes. So that, again, has taken quite a lot of exploration and meetings and understanding. So those are the kind of challenges that we're facing, which are like way beyond our previous level of experience, and we're kind of just learning these things all the time. So I think hopefully, I feel like we're getting closer, but we've got some good meetings in the next couple of weeks actually. Hopefully we'll have something before Christmas, kind of a little bit more formalized.
Basically, our life is like Dragon's Den at the moment, where we're trying to pitch people for money or projects.
Good question. That's good.
Hello, lovely presentation. I wanted to ask, like, what's the human to machine ratio of like the work separation that you do? And another thing is that when you're, as most of your work is like BIM based, do you consider like the design incorporating like separation for like electricals and incorporating other alterations in it as well when you like print your or CNC or panels?
Yeah. I'll do the BIM and you did the other part. So BIM, yeah, we model everything. So we model the ducts, the electrics, the mechanical, all of that stuff. We model almost down to the nuts and bolts. And then I guess the part you maybe didn't quite clock is in the chassis, we have all of the channels are cut into it for all of these things. So it's basically all of these things are pre-cut in place. The people that come are still kind of traditional plumbers and traditional electricians, but their job is much easier because all this stuff is just like, plug and play. And the second, your first question was like human to like machine ratio, or maybe you want to talk.
I mean, we did a presentation yesterday with Tharsus, our kind of robotics automation partner, and they were talking about strategic empathy machines. I can't remember exactly what they said, but basically it's not about removing humans. Like, it's about enabling humans to do their job better. And you can take a very different philosophy. So the example that Mark from Tharsus gave, he was like, a company that they've been talking to wanted to do robotic bricklaying, and they wanted to like lay the bricks, right? There's a few companies out there who are trying to do robots of bricklaying, and Tharsus's approach was, well, don't do the bricklaying, just automate the rest of it. Like, get a little robot to bring the bricks over, take all the stress out of it, take the weight out of it, and it's about enabling humans to do what they're good at. And in this case, we don't want the humans to be loading the machine because it's hard and dusty and not much fun and boring, but actually assembling the components. Humans are really good at that stuff. That's why the majority of our phones and other things that are assembled are humans doing it because they're good at doing it. And it's not that humans need to be removed from the process. Particularly, we see that the other advantage of manufacturing on site is as a kind of cultural aspect, which is when we used to manufacture in the factory, they would just be meaningless boxes, right? Here comes another box, don't know what it is, nail, bang, and the quality would get worse and worse because it didn't have any actual substance meaning for the people doing it. Whereas when we're manufacturing it on site, it's a house, and you make a component, another Lego block has gone in, it feels satisfying, and you see the product of your labor. So the on-site manufacturing has this other kind of net benefit in terms of quality because it has meaning for the people that are working on it. So the kind of cultural aspects of using technology, working with humans are super important, and I think you see quite often at the moment, people trying to revolutionize things and just take very unnuanced approaches, which is I'm just going to stick a robot in and try and remove humans from the equation. I just don't think it is that. Not yet, anyway. It may be in the future if that's what we want to do. But we spent quite a while looking at robotic assembly to see what the opportunities were for us, how would it work, and the answer was not now. Like, A, it's not required, and B, the technology doesn't exist to do what we need to do. Like, actually, every component that we produce is different, and the biggest cost of robotics at the moment is the programming. You can't program stuff on the hoof at the moment, like over and over again. So you have to build incredibly advanced scripting, which costs you hundreds and hundreds of thousands of pounds. So, you know, for us, focus on that kind of iterative process. Right, let's just focus on the automation of the dirty stuff. And then in the future, you know, we have a plan in the future when it feels appropriate, but right now it's not required.
Thank you.
I'm just wondering at the moment who your clients are. Are they people who are attracted to the costs or the design or the technology? Just wondering, like, for a regular person that's not interested in that sort of thing, what brings them to your company?
Well, interestingly, it's the same for the current business as it is for the future business. So think about it from a customer's perspective. In fact, before we started up the business, I did. So I used to run a small practice, and we would have, you know, a QS, us as architect, a contractor, and I would see it not go very well because everybody's working for their own interests. You're not working I mean, you're working collaboratively, and sometimes it's great because everybody's well aligned, but actually you've got a contractor who's thinking about being a contractor, you've got an architect who's just covering their risk because it is risky, you've got a client who wants to do their thing, you've got a QS who just wants to make everybody's life easy and just convince the client that it's going to be expensive and then everybody can have an easy life. And my perspective was, I don't think this is a very good experience for the customer at all. So most customers come to us because they want a better experience. They want to know how much it's going to cost and they want somebody to take responsibility. It's as simple as that. And you just don't get that. Like, you get more kind of naive clients who will, you know, bury their head in the sand and just go with the cheapest contractor and not really figure out how much things are going to cost. And they quite often end in not the greatest place. Whereas you get more, our customers are generally slightly more professional in one way or another, and they like working with professionals and they trust professionals, and they just want answers like, how much is my building going to cost? How long is it going to take? The kind of really simple questions, really. That, you know, so the number of projects we get coming across our plate where there's been a design by an architect previously, they've gone out to planning, they've got technical design done, they've gone out to tender, and then they get the prices back and it's twice or 3 times the budget, right, literally. And then they're like, oh crap, I've just wasted 2 years. And then they come to us and say, what can we do? Can we make it cheaper? And it's like, you can't make it cheaper because your design is crazy. What we can do is take a much more considered, sensible approach and know how much it's going to cost. So we quite often like either substantially remodel the design or just bin it all together and start again.
Thank you.
I'm quite curious on the sustainability of this. I mean, you're using plywood, so I'm assuming it's capturing carbon. And so, like, what is the average U value for a standard house? And then are you also able to calculate using BIM? Like, because obviously you'll have the exact amount of material you're using. Are you able to calculate how much carbon you've used?
So carbon-wise, we did do a carbon study, but it's a little bit outdated. It was about 10 years ago. So looking at embodied energy, it uses a fraction of the embodied energy of if you were going to go and build the same quality of house in terms of like passive standard house. You know, if you built it in like masonry with polyurethane insulation and a standard like foundation system, it's like I can't remember what it is. It's like 5 or 10%. It's so much lower. It makes more of a difference, actually, the embodied energy when you're building passive house standard, because you've got more stuff, you've got more insulation. If you're building a minimum standard building envelope, it makes less of a difference. But I think, as far as we're concerned, I think you just struggle to build a more sustainable house in terms of its like material selection. There's just not much to it. You know, it's like EPS insulation because it's got a low embodied energy over polyurethane, minimum amount of concrete, as much timber as possible. Yeah, so we try and be as sustainable as possible, whilst also commercially viable as well. So, you know, insulation is a tricky one because there aren't many insulations on the market which are really truly sustainable. So it's the best of the options. You know, that's why we'll go for an EPS over a polyurethane, because it's got a lot lower embodied energy, still a petrochemical product, you know, and then if you're into non-combustibles, you really don't have much choice. So sometimes it's just is what it is, and you have to do your best. But we also can try and look at things broadly. You know, like sometimes we fit like rainwater harvesting tanks, and I just don't know if they're really sustainable. You know, they're a big plastic bucket buried in the ground, covered in concrete, and I'm like, is that really sustainable? You know, because it's quite often it's just a cost thing for the client. You know, if you look at the carbon footprint of a litre of water in the UK, it's literally nothing. It would take like 1,000 years to get the carbon footprint back for what you've buried in the ground. But, you know, it's not always our choice. So some of our customers will fit PV panels, some won't. Always air source heat pumps at the moment is the thing, but always with the same like really good quality building envelope. So we're not building passive house, we're building passive standard. So the U values are passive standard. The air tightness is not passive house. So we're usually at like 1.2 meters per meter squared, whatever it is, as opposed to 0.6. So we're at 1.2 rather than 0.6, but the building regulations is like 4. So we try to be as optimized as possible, as commercially viable as possible, because it's all very well going, well, I'm going to be the most environmentally passive standard, passive house, everything, but you'll build less of them if you can't get it to a commercial level. So we've got to balance that out.
Great, thank you.
I think we've. Oh, one more question. Just one more. Is that okay? Yeah. We'll keep you going all night.
Firstly, thank you for the informative presentation. I just wanted to ask, obviously in the future you're looking at affordable housing. Have you thought about what steps you would take in your processes you have already to try and make the housing more affordable?
Yeah, I think there's you know, I think it's like the Tesla kind of analogy, right? You start at the top end of the market and scale down. I think with scale becomes like a scalability of economics. So the more we build, the more, you know, the cheaper we can build for, which allow us to build more affordable housing. There's also a component about the typologies of homes. So we don't want to go down the route of a copy-paste home, but you know, we can build completely customized homes, but there's something in the middle where it's kind of mass customization, where you're using computation and parametrics, where it's like, it's the same typology, but it's parametric. It can change size, it can change the shape of the roof, it can change the facade. And I think that will enable us to, again, make you know, more efficiencies where like, we kind of know 90% of the building is like, pretty much pre-made, and then there's 10% of customization from the exterior, but also to the interior. So I think it's just like loads and loads of incremental steps. Like the faster we can make the design process, that's a cost saving. Eventually we'll optimize the building system itself, so it's like super optimized using the absolute minimum amount of material that we need. And you know, we're there, and then also able to speed up the design process and the build process, and it's just going to drop the cost further and further down. Outside of that, I guess maybe there's us rethinking finance, but that's like a whole can of worms. But yeah, I think that's kind of the philosophy.
Well, thank you so much. It was fantastic to see what you're doing, and also a great presentation of your work and your kind of whole approach. So thank you so much. That was brilliant. Thanks for coming.
Thanks for having us.